So we're talking about file processing. The idea behind this, and this doesn't necessarily just apply to files, but anytime you have a series of data, a control break is a temporary detour in the logic of the program, meaning it's looping, but it's got to stop and do something for a little bit, and then it starts looping again. Maybe the simplest example is, what if you were making a typewriter, right? You hit enter, hit enter. At a certain point, you're going to hit the end of the page, right? You got to tear that sheet of paper out. You got to put a new one in. That's your control break, right? That's, you know, you're doing that, not the computer. But it's the same idea. You know, every once in a while, you have to stop what you're doing to do something else, to take care of something else. So a control break program uses a change in a value to initiate special actions. Change in a value. I don't know. You know, you get to the end of the page. If that variable becomes true, you kick that page out and put a new one in, something like that. But we're going to give a better example here. A control break report will group similar pieces of data together. For that to work, the records need to be in sequential order. So, for example, here's what we want our report to look like. We want to be able to open the file, and all this part, except for this count for Alabama and this count for Alaska and stuff like that, this is stuff that's in the file. It's got a name, it's got a city, and it's got a state. A name, a city, and a state. A name, a city, and a state. And this has been sorted in such a fashion that it looks like it's sorted by state name, and then by city name, and then by the person's name. Okay. Like if you've ever used Excel, you know you can do that, right? You arrange your items by certain orders. But this is how this one has been arranged. So as it's going along, it reads in an item, it reads in an item, it reads in an item. It is storing the last value of the state in a variable so that when it pulls the next one in, it can go, oh, our state has changed. We're no longer in the Alaska series, we're in a new one. So I'm going to print out how many Alabamas we actually had. There were 3 records. We reset that counter back down to 0. We set our last state equal to the newest one. We start processing again. And as long as the last state is equal to the newest one, then we're all good. But eventually we're going to get to Arizona. And so before we do anything with Arizona, we're going to go ahead and print out our count for Alaska. We're going to print out a blank line. We're going to reset our counter again. And then we're ready to jump back into the game there. All right. So not that the people at home could see this, but if you were going to play chart, it would look something like this, right? We have some kind of loop, and it's doing something over and over and over. But in the body of the code right there, in the body of the block, there's going to be some kind of if statement. And if that case is true, then it's going to go do something else before it comes back into the loop. And so that's the control break. So examples of control break programs. All employees are listed in order by department number, and we want to kick out a new page every time we start a new department. All the books for sale in a bookstore are listed in order by the category, with a count following each category of book. You know, we have 17 self-help books, we have 32 recipe books. All items sold in order by date of sale, with a different ink color for each new month. We already hit that slide because it always boggles me that they think that they have 12 different ink colors, one for month. Anyways, that's kind of odd. So a single level control break, that's a detour based on the value of a single variable. Uses a control break field to hold the previous value. So I believe the last time we were here, we were creating a data file that we could use for this assignment. Not totally sure of that. Let me load up idle and go to recent files and see what we have here. So I'm loading up idle. We could just recreate it again. It wouldn't take that long. If I do recent files, a list of books, is that what we were doing here? No, that's a homework assignment. Alrighty. Let's make a new one. So I'm going to do File New, File New File. Make sure you save this file in the same directory that you're going to be putting your script, right? So File, Save As, put it in your favorite script directory. And let's just call it department.txt. Whatever you want to call it, but you know, department.txt, because it's going to be a text file with the employees of a department. And I'm going to say text files, right? Save as text file so that it doesn't give it a .py extension, even though we typed .txt there. Alright, so the format of our file. I'm going to put a little comment here, but we're going to write our program in such a way perhaps that it ignores comments. If not, we'll delete it. So department number. Or maybe we'll even give the department a name, but that requires, you know, too much typing. And then the name of the person, and then their title. That's enough. Let's not throw any numbers in, you know, like how many hours they worked and this, that, and the other. Let's just kind of try to keep it pretty easy. Okay, so we just need to make up some data. We're going to say 1 is management. Alrighty. And so we have Joe Bob as our manager. And he's the president. Same department. So I'm just separating everything by commas. And I should go and delete the spaces out. Not the space between a name, right? But, you know. So somebody else in there. Just start putting names in there. You know, Fred Flintstone. You know, he's the Chief Financial Officer, CFO. And then Wilma Flintstone is the, who knows what all, you know, Vice President of Sales. So there we go. We have 3 people in Department 1. Now create a few more records. Make some that are in Department 2 and some that are in Department 3. Again, the names don't matter. Bugs Bunny, engineer. Elmer Fudd is also an engineer. Department 2 must be the engineering department. And Porky Pig, engineer. Maybe one more. Daffy Duck, engineer. Something I can help with back there? Hey guys, we're working on a problem back here. What's up? Oh, that's good. Yeah. Alright, and then some people in Department 3. Mickey Mouse is in sales. Donald Duck is also sales. And that's really enough, right? I mean, we don't need to just type data in forever and ever and ever. Okay, so we're going to write a program that'll read this data in, that'll split this data up into an array so that we could print the 3 items out individually. Maybe we'll even skip printing out the department number. Who knows? And then, yeah, every time the department number changes, you know, it's going to kick out a blank line or something to make the report look a little bit better. So here's what I'm imagining the report to look like. I'm not going to type in the same thing. You know, here's what would be cool. Is if it said Department 1, and then it said, you know, Joe Bob, President, right, Fred Flintstone, and so on. You know, everybody who is in Department 1. And then it said Department 2. And then so on. Bugs Bunny, Engineer. And so on. That's what we wanted to say. And then Department 3, right? That's how I want it to look. So we're going to have to write a program that'll open this. So it's going to do a little bit of file I/O. So let's ask the user for the file name to open, and then we'll have a loop. The loop's going to read the file. But we're going to be doing a control break whenever the department number changes. So we're going to need a variable that keeps track of the last department read. And that will be our control break variable. And whenever the last department read doesn't equal the current department read, we know that it's time to do our control break stuff and to print out a new header. So let's open that up in idle and do that. Do a file new. Save as. May 3. All right. So name. File example, control break, employee report. So let's ask them for the file name. File name equals input, parentheses, ask them a question, open what file. Then let's actually get that file open. File is equal to open, parentheses, file name. Now don't get those two things confused. One's just the name of the file. The other is the thing that we read the file from. So from here on out, unless I just have a print statement, I'm probably not going to use the word file name again. Alrighty, so we know we're going to need that control break variable. Last department. Last DEPT equals, we don't have a last department yet, so it's just an empty string. Now, a file could be treated like it's a list if we use a for loop. You know that for value in array or for value in list syntax we've been doing? We're going to do the same thing. Except instead of using V, I'm going to put line because it's a line of data. You know, normally I've been doing this, right? Don't type that V, you know, something like that. But instead I'm going to say for data or for line in the file. Firstly, let's just print the line out, just to make sure that our program is working, right? Because if it's not working, then who cares about what else? And then let's print a done statement. We should also close our files. So before or after that done statement, I'm going to do a file.close, parentheses in parentheses. For every file you open, you need to close it as soon as possible. I know I've mentioned why already. Alright, so hopefully when I run it, and I type in my file name, dept.txt, it didn't print anything. I've done something wrong, and I wonder what. I never saved my department file, right? If I go back to my department.txt file, it's got an asterisk up in the file name. It means I never saved it. I typed in all that great data, and I never saved it. So save it, and then try it again. Maybe it worked for y'all. Maybe y'all were smarter than me. Let's give it a shot. Department.txt. Okay, it's printing it all out. And I think the last time we did this, we noticed this as well, right? There's all these blank lines. Those blank lines means that it's a line of data followed by a /n, that \n. The \n stands for a new line. We don't see the \n because any time that the print statement finds one, it you know, just does a new line. So that's why we have all these blank lines that we didn't see here. We're going to remove those blank lines with the strip command. So Line equals line dot strip. I put that above my print statement. I want to remove all the blanks at the end. It will also do that. Any /ns at the end. Okay, and it printed them all out. Or at least it printed one of them. I'm not sure what I'm seeing there because I thought I would see a lot more data than that. Okay, there they are. There they are. Good deal. Now what we need is we have 3 chunks of data, right? I want to be able to say, okay, that piece is department, that piece is the name, and that piece is the title. The easiest way to break data out in this language, when you have a string of data, which is what we have here, it's actually a string of data and it's separated by commas, is to use the split command. We can split it into an array of data, a list of data. So I'm going to do that. So data is equal to line.split. And how do I want my data split? I want it split based on commas. So that's a comma, not a period. If I wanted it split on tabs, if we managed to create a tab delimited file, I would do a /t there. You know, really, you could split on anything. If we had gone into our text file and, you know, we had decided that the data was all, whoops, that's not our text file. Where's, you know, I could have used as my delimiter any symbol that I wanted to. What if I liked 3 colons, right? You know, or, you know, backslashes or whatever. But, you know, commas are perfectly good delimiters, so I'm not going to change that. Okay, let's comment out this print line. We already know that part's working, so let's print our data out instead. Print parentheses data. So I just commented that line out, and I added this line. And remember, you don't have to type in my comments. Those are just when I'm highlighting the last change I've made. Okay, I accidentally opened the wrong data file. I opened a file from last Tuesday, so it printed out something completely different. Need to run it again, give it the correct file name. What happens if I type in a bad file name? It blows up. Now there's a way we could check to make sure that that file was there or not. And oh, by the way, I meant to do this and I didn't, but on the open command, right here, where it says file is equal to open, you can specify that you want it to be for writing. So when we wrote our files out, we did comma, quote, W. But that would erase the file if we left that W there. So opening it for reading is what we want. But by default, that's what it does anyways. So you don't have to put that comma, quote, R there. But I like to do that, and I didn't mean to leave it off. So that's why it worked anyways without doing that. But if we tried to open it for writing and we didn't have the comma, quote, W, it wouldn't be able to write to it. All right. I still haven't run it successfully. Let me see. dept.txt. There we go. Now you see, it's no longer just a line of data. It's an array of data, right? It's a list of data. We can tell that it's that same syntax we've been using, right? The square brackets and everything separated by commas. So we can do stuff with it. This is element 0, that's element 1, and that's element 2. So we could say department is data 0, name is data 1, and title is data 2. But I haven't made it where it will ignore things that begin with a hash. I think I'm going to just... Yeah, we need to rule that out right from the beginning. So we're going to do a check. Even before we do anything else, even before we strip off the stuff at the end of the line, if the first character of the line, and there's more than one way to do this, but here's the easiest one. If line at position 0 is equal to a pound sign, a hash, then we don't want to do anything else, so we're just going to continue. Remember that the word continue does the same thing as a break, except continue causes it to go back up to the top and keep running, whereas break causes it to exit the loop. Okay, that way it just won't print out that line of data that I had in there as a comment. Right? That looks better to me. These were just kind of headers. I don't care about those. Alrighty, so let's get our data out. Let's get the department out, let's get the name out, and the title out. So we need 3 variables. Name is equal to data to subscript 0. No, that's the department. The department's the first column. Sorry. DEPT is equal to data subscript 0. Name is equal to data subscript 1. And title is equal to data subscript 2. We could just print those 3 things out. Why don't we just print those 3 things out for now, make sure that everything is working great, but then we're going to modify this a little bit more. So print, department, comma, name, comma, title. All right, and we see that it's working. We're getting too many print statements, so it's looking really cluttered, right? But we see that we changed this array of data into some variables that we could play with. And if we wanted to do math on any of them, we could convert that to a float, like department equals float department, something like that. But we're not actually doing any math with the department number, so I'm going to leave that alone. Okay, so this printing is kind of extraneous. We don't need to see that array anymore. I'm going to remove that line. This printing of those 3 things is kind of extraneous, so I'm going to remove that line. As a matter of fact, I may just want to delete all those print statements. They're kind of cluttering up the scene. So what's our logic? As soon as the department number changes, we want to print out something, saying this is department whatever. Well, the first line of data, the department number has changed, right? Because we didn't even have a department number beforehand. So we're going to put an if statement here. If department not equal last department, then do something special. Print out our report header. So if the current department, if DEPT not equal last department, LAST DEPT, well, then we've entered new territory. So we need to print something out. Print department, end quote, comma, DEPT. And then we need to assign that last department value equal to the current department, right? Because we switched departments down. So last DEPT equals DEPT. Now you don't necessarily have to run it at this point, but I want to show you, just kind of test it. DEPT.txt. All right, that's what it did. It printed out department 1, department 2, department 3. So every time the department number changed, it printed something. Our control break code is working. But now we need to print out that employee. So after the if statement, not indented under it, but, it's a tab back one. Let's print their name and then their title. And I'm going to put a comment up here that this is example of control break. All right. Now we could make it look a little bit prettier, our report here. I can only think of one thing that I'd really like to do, but I think blank lines kind of make this look nice, right? Department 1 and then print out some people. Department 2 and then print out some people. Department 3 and then print out some people. I think there ought to be a blank line before and after the word department. So we're going to fix that. Blank lines are \ns. So I'm going to put a \n. That's the one above the enter key, not under the question mark. Don't go for the slash under the question mark. And then at the end of the word department, I'm going to do another \n. dept.txt, and there's my report. Okay, I kind of goofed. There's something there that looks pretty dumb. I didn't really want the department number to be on its own line, so there's something I need to fix there. But it's getting there. It's getting there. Just take that last \n off. Why was that wrong? Because it printed out the word department, and then it went to the next line, and then it printed out, right, the actual department number. So that was lame. That needs to be fixed. Get rid of that second \n, and it'll be about time to wander around and make sure that everybody's got this going. So there's our program from top to bottom. And I know I usually need to scroll it back up. All right. If you're seeing this particular error, it's something that we should have taken into account. What if there are blank lines in our data? We should probably ignore those just like we ignored the comments, right? So if my code looks like, did I actually close my data file? Apparently I did. Right, my program would crash if I had a blank line at this point in my data, in my input. I wasn't trying to run you, I was trying to run the other one. Okay, so there we go. dept.txt. There we go, and it blows up. So if you're seeing list index out of range, it means that it's hitting a blank line, but it's treating it like it still has some data. Let me go back and add a print statement that we removed to show you why. So I'm going to just print out the line of data once we read it into that array. So there we go. We read it in. Department.txt. We'll get it fixed in just a minute, but I wanted to zero in on exactly what was going wrong. You see here, we have an array that doesn't have any data in it. Or it's only got one piece of data in it, an empty space. So when we said department was equal to element 0, name was equal to element 1, title was equal to element 2, okay, department, that doesn't crash it, but then name is equal to element 1, there is no element 1, right? There's nothing in there. There's nothing in that array except for the first one. So we need to fix our code so that it not only ignores lines with a hash symbol in front of it, but also if the line doesn't have any data. Another way to think of that is, does it have a length of 0? You could use len00. I'm going to move this check down here to underneath the strip command, or I'm going to move the strip command up, mean the same thing, because I want both of my if statements in the same place. So I'm going to grab that, line equals line.strip, I'm going to cut it, I'm going to come back up here and make it the first thing in my loop. Then we're going to do if line is equal to quote quote. That means it's empty. Or I could do if len line equals 0. If len parentheses line is equal to 0, equals 0, then continue. And let's put comments about what's going on here. Ignore comments in text file. Ignore blank lines. Now, if you're thinking to yourself because you didn't see this error, oh, I didn't have any blank lines. Why would you have put any blank lines in your code? It's real easy. What if you just hit enter there? That's a blank line. So it runs all the way and then it crashes at the end. I'm going to leave that blank line to make sure it no longer crashes it, but you don't need any blank lines in your data file. But if you had one, it's probably at the end of the file. dept.txt. Ew, it blew up. String index out of range. Okay, I still don't have these checks in the right order, right? I can't check to see what the first character is if the length of it is 0. I need to reverse these two statements, and I apologize for making that mistake. This one that says ignore blanks needs to be cut and put above the other if. Cut, paste. Now we are good to go, I hope. Alrighty, so open what data file? dept.txt. Oh, and I have that extra print statement I'm going to have to remove. Right, I don't want any prints except for these two print statements down here. So this was a debug print that I need to get rid of. Eventually you're going to need to comment out or delete every print statement except for the one under the if statement and then the last one. Well, and then a done at the bottom if you care. If you care about deleting that. So open what file? What's more? And there we go. There's our cute little report. I'm not really digging the done at the end of it, so I am gonna delete that last print statement. The only reason it's nice to have a done though message is because what if you didn't have any data at all in your file and it just ran after you typed the file name but you didn't see any output. I'm going to change that just slightly. I'm just going to put a slash in there. That'll make it look prettier. So I modified my done statement to have a backslash in front of it so that when I run it, it's at least separated from the report. All right, now it's time to do another walkabout. Okay, so there's our department report. Now there are examples in the book show counting these things. Right, we could have a counter. The counter increases, but every time that control variable is reset, we reset the counter as well. So we would print out the total employee count, we would reset the counter, and then we would start working again. What we want to do now, I'm going to make a new text file, which is going to control a turtle. So file, new file, and here's what I want my turtle to do. I want to be able to issue a command. I'm just going to free type right now. Don't follow me. I want it to do something like this. Go up, right, turn right 90 degrees, right? And then forward, heck, we could, even abbreviate these things. Right 90 degrees, forward 100 pixels, left 45 degrees. Circle with a radius of 100. That kind of stuff, right? We want to be able to control the turtle not with commands in our file, well, with programming commands, but to open a file. So, for example, if I wanted to draw a square, what am I going to do? I'm going to go forward a certain length. I'm going to turn right 90 degrees. I'm going to go forward a certain length. I'm going to turn right 90 degrees, and I'm going to do that 2 more times. One, 2, 3, 4. Right. As a matter of fact, let's go ahead and do that. Go ahead and make your file look like that. So let's do a save as, a file save as. And what am I going to call this file? I think I'm just going to call it TC for turtle commands, or TURT, something like that. Don't call it turtle. And then .txt, and make sure you save it as type txt. And so I'm going to add a comment up at the top that says turtle commands, just so that I know. So that means that we're going to have to make our loop ignore lines with a hashtag, just like the other one did. And also we're going to have to make our line, our code, ignore empty lines, because what if I had a, blank line there? Sadder but wiser. We'll put both of those changes in from the beginning when we write our next program. So what are we going to do? We're going to ask the user for the file name. We're going to open the file for every line of data in the file. If it starts with a hash, we're going to ignore it. If it's a blank line, we're going to ignore it. And then we're going to check. We're going to read it into a data array. And if that element is equal to an F, we're going to go forward. If that element is equal to an R, we're going to turn right. That kind of stuff. I think we ought to put it in a separate file rather than just put everything into May3. So let's do a new file and put your name up here and this turtle commands from file. That's what we're going to be doing. So file save as, May3 B, or whatever you want to call it, something different than the other one. May3 port 2. Alright, a lot of this is going to seem similar because when you're dealing with file I/O, you do the same things, right? You get the file name, you open the file, you have a for loop, all that kind of stuff. So, but we're also going to need to make a turtle, right? So we're going to have to do that import turtle stuff. But let's not do it until after we ask the file name. Because if you do the import turtle and you make your turtle first, it's going to pop up the other window and they won't be able to see the question that says file name. So, file name is equal to input, parentheses, quote. What is the turtle input file? Now let's open our file. File equals open, parentheses, file name, end quote, or comma, quote, R, end quote. Now let's import our turtle and make it. Import turtle. I'm feeling really lazy, so I'm just going to name my turtle T. T is equal to turtle, all lowercase, dot, uppercase T, turtle. And then don't forget the parentheses and the end parentheses. Alrighty, let's do our while loop. Or excuse me, it's going to be a for loop. For line of data in the file. So for line in file, colon. Now we need to ignore the blank lines, we need to strip it, we need to ignore the hashtags, so this code is going to look very similar to our other one. Line is equal to line.strip. Remove any leading spaces, remove any trailing spaces, and remove any \ns. That's what that does. Alrighty. Then we can do if line equals empty, like that, there's no space between those quotes, then continue. Don't do anything with this data. If line subscript 0 equals quote #, continue, because we don't want to do anything with that line, it's just a comment. Now we have some good data. So in the last program, how did we convert our line of data into an array? What command did we issue? I hear somebody almost saying it, or maybe actually did and my hearing's bad. Which line of code over here actually turned our data into an array? Yeah, the split command right there. I should have even commented it. Turn line of data into array, or into a list. So, let's go back and do that. Here we go. So, data is equal to line.split, And this time I'm not splitting based on commas because my input file didn't have any commas, did it? I could have made it had commas, but I didn't. I used spaces. So don't split based on commas, split based on spaces. So use a quote, a single space, and another quote. So this is our delimiter. We didn't delimit it with commas, we delimited it with spaces. And so the command is the first letter, right? The forward or the right. So CMD is equal to data subscript 0, the first element in the array. And then the value is equal to data subscript 1, right? How far it's going to go, how far left it's going to go, how far right it's going to go. But what if there was no value? We may have to go back and fix and revise this. And here's what I mean. If I went and I modified my turtle input file so that we had other commands, like to lift the pin up, it was a U, and then to put the pin back down, it was a D, something like that, right? We may have commands that don't accept any values. In which case, that would blow this one up, right? Because we'd only have one element in the array. We would not have two, so we would only be able to access element 0 and not 1. But we haven't decided what that we're going to have these yet, so we're just going to get rid of that. Firstly, let's just print stuff out before we actually draw anything, right? Why make things more complicated? So print parentheses CMD comma value. And then at the very end, as always, file.close. Oh, and there's another reason I'm suspicious of this, right? Because that's supposed to be a number, but when we read it in, everything you read in from the file is going to be a string, so we're going to have to convert it into a number. We know how to do that, but let's fix that later. Okay, so what is our turtle file? I called mine turt.txt. And there's our commands. So it is reading the data incorrectly. Mine is. Now we're going to set up some if statements or something like that. If the command is F, go forward. If the command is right, turn 90 degrees. So I want to make sure everybody's got what I've got. Got it working before we go on to the next. So I think we ought to convert this to an int or a float after we read it in, because it's going to be a number, right? We're going to go forward 100, we're going to go back 100, something like that. So value is equal to float value. And we don't really need to print our command out, but I'm just going to leave that there, you know, for now. But we do need an if statement. If command equals quote F for forward, then send our turtle forward. T dot forward parentheses value end parentheses. If CMD equals R for right, if CMD equal quote R quote colon T dot right parentheses value. Now those are the only two commands I put in my data file, right? But then I'm going to do, you know, a left and a circle command, stuff like that. But I want to see it work like this. So what is the turtle input file? It is turt.txt. It drew all that stuff, and I hope it was actually drawing a picture as well somewhere. There we go. So it did draw a square. I just didn't, I had it covered up. I didn't get to see it. Still not getting to see the draw. Everything's in the way. Whatever. I know it's working because I tab over to the window and I see it done. It'd just be more satisfying if I watched it get to draw. Okay. I think what I want to do, one little change to it, is instead of making it just if, I'm going to make it elif. So if command is equal to F, do that. Elif command equals R, do that. Else, colon, print, quote, command, unknown command. That's easier to type. Unknown command, end quote, comma, CMD. Right, so that if we have something else in there that we haven't implemented yet, like I went in and I threw in a C expecting it to draw a circle, but I hadn't put that in my code. Excuse me. All right, there we go. So it drew a square. Let's mess with that a little bit. Let's modify our data a little bit. Go back to your turtle.txt file, turt.txt. And then let's have it move somewhere and then draw another square. So why don't we just go forward 100 again. F space 100, but no, wait. Yeah, F space 100 again, but then copy all of these lines from the first F100 all the way down to the right 90. Copy and paste that and put it underneath that F100. So I copied all those, I added an F100, and I'm going to paste them. And now I should see it draw two circles. All right. So we've created a little language for the turtle to obey. We can make it draw as many squares or any other things that we wanted to just by modifying that text file. What else should we make the turtle do? Going left seems obvious. Drawing circles seems like a good idea. Let's add those commands. So, elif command equals right, t.right, and we're going to add another one. Elif command equals left, t.left. Elif command equals quote, L quote, t.left value. Elif command equals C for circle. I'm saying quote, but I mean colon. I'm sorry. Quote C quote colon T dot circle at that value. And we could get all fancy and support begin fill and end fill and lifting the pin and lowering the pin and go toing an XY coordinate. Right. All that stuff would be fun if we really wanted to make this a good drawing program. But I'm happy enough to leave it like this for now. Well, I didn't add any commands to my text file, to my data file, so even though I have those new commands in my program, nothing uses them, right? Because I didn't put any L's and C's in my code. And I didn't mean to close my program. That was dumb. But anyways, so let's go back here and let's add a couple of things. Let's draw a circle somewhere. I don't know. Just pick a place and add a C space 50. And then pick another place and add a C space 50. Just so that it's drawing circles somewhere. Turned out better than I was expecting. Anyways, you see what we've done? We've created an input file that controls the behavior of the turtle. So we can make the turtle do all sorts of things, draw as many squares, as many circles, as many lines as we want. So maybe down here at the bottom of our turtle commands, I don't know, left, trying to think, but nothing happened. 120 degrees, forward 50 degrees, and then copy and paste those lines 3 times. So I wanted to say left 120, F50, left 120, F50, left 120, F50. What's that going to draw? Not going to draw a square because our angles are no longer 90-degree angles. Yeah, it's going to draw an equilateral triangle. If I could get all this where I wanted to, it'd be awesome. Alrighty. All right. Now, by all rights, I ought to think of more things to add to the program and ask you to write them or to draw a picture. But I don't know. Maybe we've gotten enough out of this exercise. What is the real key here? That in order to get this to work, what did we do? We got our file name. We opened it. We processed the file with a for loop. Depending upon the data, we did something. It might be useful to split this off into its own function, right? Because otherwise, if we made this thing do 100 different options, then that part of the program is going to get very long. And it would be neat. Don't necessarily add this. But if I had something that said process command, and I passed in the command and the value, and then the rest of this code was all in that process command code, right? That would be kind of neat. That way all of this stuff would be somewhere else. But let's not do that. We are actually just about done with the PowerPoint, because the rest of them are pictures and code dumps. Alright, so there's a little bit more to mention, but we're not going to write any code that does it. Merging files! Combining 2 or more files while maintaining this sequential order of the records. So, right, what if I had 2 lines of people and y'all were lined up in alphabetical order? But I wanted y'all to get into one line, right? One great big line. And still be sorted by alphabetical order. What I'd have to do is I'd have to go, okay, you, you. And then we'd have to keep doing that, kind of zipping the files together until they were all in one list. So you could have a file of current employees in ID order, a file of new hires, or you have a file of parts manufactured at north side and another file of parts manufactured by south side, but then you want to combine them into just one list. So 2 conditions are required. Each file does have to have the same record output, right? Same record layout. We couldn't merge our turtle file with our department file. And then they have to be sorted in the same order, right? So we could have 2 department files as long as they were both sorted by department. Then we could produce an output file that was a combination of both of them. So their East Coast file, Abel 100, Brown 50, Doherty 25. Their West Coast file, Chin 200, Edgar 125. And then they merged them. Abel 100, Brown 50, Chin 200. We're not going to write this program. I just want you to have kind of the idea in mind. To merge a file, they need to be sorted in the same order, and they have to have the same record layout, just like these do. See what I mean? Lots of code. Okay, master and transaction file processing. You could have one file that was a list of all your employees. And then you could have another file that was just a list of only changes that happened today. Yeah, we fired 3 people and we hired 2 more. That file would be very short, right? And then you'd have a process which go and you update your master file based on the transaction file. Or you have a file of inventory, a master file of purchase orders. And then you just have today's purchase orders, right? The complete file of purchase order may be hundreds of thousands of records long. You know, you've made a lot of sales. But today's orders may just be a couple of items. That's your transaction file. And then when you're ready to process them, you open that file and you update your master file with those. You have a student database. And then you have some students who are coming to enroll in. Well, you created just a couple of transactions. This person wants to enroll in this class. This person wants to enroll in this class. And then you can update your master file with those student enrollments. My examples are just as good as theirs, so I'm skipping that. So updating approaches. You could change the information in the master file, or you could copy the master file somewhere else and change the new one. And then eventually, you know, shuffle the file names to get it back. Doing this one is the idea of using a backup copy, right? You copy the master file to a brand new file, then you make changes to that one. Then your original master file is now your backup. You'd have to rename the files, which you can do with your program once you were done with that. But then at least if it failed halfway through, you haven't lost your original master file. If you're doing some process, you know, if you're updating hundreds and hundreds of thousands of records, then it can take a while, and it's an actual possibility that the program would stop or the computer would reboot during the middle of that. So that would be a concern. So random access files are something different. We've been using sequential files, right? We open it up at the top, we read, and then we close the file, we're done. A random access file is when it'll jump around inside the file, reading in any line that you want. And that's really closer to what we think of, like when you're doing databases, right? You log into Oasis and it pulls up your list of information, right? Your classes you are enrolled in. It didn't start at the top of it, of that file, read all the way down until it found your records. Instead, it used some kind of index so that it could jump just to the right records, pull it in. And all of that was managed by a database rather than us having to write the code ourselves. And when you go and you take a database code, that's what you're going to be doing. But those are random access files so that the reads can happen from any place to it, and then the writes can happen to it any place. We've been doing sequential, right? All of our writes happened at the end of the file. Every time we did a write, it just tacked it onto the end of the file. So real-time application requires that the record be accessed immediately while the client is waiting. Right, you go down to talk to Steve Johnson downstairs because you want to enroll in a class, but it says that you don't have the prereq, right? He needs to pull up your records. That needs to happen immediately. And then he goes ahead and enrolls you in it, despite that prereq not being met. You want that change to be saved immediately. Why? What if the class doesn't have any other slots left? You don't want it just hanging out, waiting there while somebody else runs in and logs in and enrolls in that class. So real-time processing means that the records are accessed immediately and updated while the client is waiting. And an interactive program is a program in which the user makes the direct requests, right? Because you can have batch processing. Like you work for the state and you find out that, you know, everybody's getting a 5% raise. Sounds great. You could write a batch program that would run through all the employees and give them a 5% raise, right? You could start that program and then, you know, go to lunch while it runs, whatever. That's not an interactive program. An interactive program is when you make the direct request. You pull up user, you know, person 1, you type in arrays. You pull up person 2, you type in arrays, and so on. Get the idea of the difference. A batch is when you're doing a whole bunch of things at once without you doing any intervention. Most of the time, we do interactive programs, right? We type stuff in, we see our results immediately. So random access, the records can be physically located in any order. If you went and you looked at the files in Oasis, you know, Bob's record may not be after Abe's record. They're not going to be in any specific order. It's up to the database to keep the order in its brain or in its file system by use of an index. And so instant access files are files in which records must be accessed immediately, also known as direct access files. And honestly, I'm going to have to go and look at the book to see why they're even mentioning that. Because what's the difference between an instant access file and any other kind of file, right? You still want the records to be accessed immediately as soon as you ask for them. But I need to read that page again. So if you have sequential access, you start at the beginning and you go to the end. If you have random access, you have something that tells you, oh, I need to jump to this spot and read it. Kind of like an array, right? We can process arrays with a for loop going from beginning to end, or you could say, I just want element, 5 out of the array. 0, 1, 2, 3, okay, 4, element 4 out of the array. So an array is random access. You don't always have to do them sequentially, although we have been a little bit. So our summary. We need to make our Dropbox and leave. What is a computer file? It's a collection of data stored on a non-volatile device. Data items are stored in a hierarchy. You remember that? Databases are composed of files. Files are composed of records. Records are composed of fields. Fields are composed of characters. To use that data file, you open, read, write, and close to it. And you know what a sequential file is. I'm going to leave the last 2 summary lines off so that we can make our Dropbox. Alright guys, if you refresh your Dropbox, you'll see Dropbox T. Go ahead and upload both of your PY files and both of your .txt files there, please. Alright, if you need to hang out and talk about homework, we have a little bit of time in which we could do that. I don't think I'm going to drop any new homework on y'all. Y'all still have that list assignment. It's not visible. Alright. Plot twist. Homework 13 wasn't visible to y'all. It was hidden. But y'all knew about it, but I'm going to go ahead and make the due date due a week from today rather than a week from Monday. Alright. So don't forget about that homework. Just because it wasn't showing up, it's there now. Homework 13 based on what we talked about on Tuesday. All right.